It's time to talk names and types of polynomial functions. So, names and types of polynomial functions. So, here's what we are going to cover today. First things first, you're going to have a specific name based on what's called a degree. So, based on degree. This is potentially a new vocabulary term for you, where the degree is the highest exponent on x. Okay, so the degree is the highest exponent. So for the example on the previous slide that I'd written up where it was negative 3x to the 7th, that was a 7th degree polynomial. So the degree is simply the highest exponent involved. That's it. That's all that we care about. What is the highest exponent involved? All the other ones that are less than that highest exponent just fall by the wayside. So we're going to start off with some pictures because I like to do things in pictures. So we've got a horizontal line, a diagonal line, a semicircle, a triangle, a square, and a pentagon. And we're going to use each of these to hopefully lock in the name, degree, and standard form for these big 5, I'm sorry, I can count, these big 6 polynomial functions. So we're going to start off, hang on, let me get myself straight here. There we go. We're going to start off with this horizontal line. This horizontal line is called a constant function. It has a degree of 0, and its example would be f of x equals any number, no x. Okay, so for example, f of x equals negative 12. That's a constant function. It's just a number. What this is implying is without that x, there is no change. It is constantly negative 12. You don't have any unknown variable x making things change, so we call it constant. It's just going to be that value the whole way through. So type 1, constant, degree 0, it's just a number. All right, type 2, linear. Okay, type 2, linear. That has a degree of 1. And the criteria here is that you've got f of x equals x to the 1 power. That's the biggest x that you've got, and you've only got the 1. Now, if you wanted to see this, this is a classic y equals mx plus b. You could use y equals mx plus b because m and b are numbers. Like, they aren't extra variables there. They are going to be locked in and create that value. Linear functions are either diagonal downwards or they're diagonal upwards. All right, they are never vertical. Just keep that in mind. There is no vertical here because vertical lines are not functions. Vertical lines are not functions. All right, so far we've got 2 types of functions. We've got degree 0, constant, degree 1, linear. Now we're going to go to degree 2. Degree 2 is called a quadratic, which you know. We've talked about that multiple times because the highest power for a quadratic is a 2. So a quadratic can look like this. F of x equals ax squared plus bx plus c. But the minimum requirements, the absolute least amount that is needed here is just x squared. That's the minimum requirement. Okay, just x squared. That's the lowest that we would need here. Degree of 2, ax squared plus bx plus c is quadratic form, and then the lowest degree, the lowest thing that is the minimum amount to make it a quadratic is simply to say x squared. You have to have that degree of 2. Okay, now here comes some fun stuff. We're going to go to the triangle because the triangle has 3 sides. And this is called a cubic function. Anytime you have a degree of 3. The reason it's called cubic is because you're literally cubing the x. So the standard form here would be ax cubed plus bx squared plus cx plus, oh, I ran out of space, d. All right, that's what the standard form would look like. That's as big as it can get. But the lowest that it would need, the absolute minimum requirement, would be to say x cubed. That's the lowest that we would need here. We wouldn't need the x squared, the x, and the d term if we had the x cubed. Just having that degree of 3 is enough to force it to be a quadratic, a cubic function. A cubic function. All right, we've got 2 more for this slide, and then my video is complete for this video. And we're going to go ahead and look at this square here. Well, in case you haven't figured my pattern out yet, the square is going to be a degree of 4, or I should say degree equals 4 because that's what I've been writing. And this is called a quartic. All right, quarter, 4 quarters in a dollar, 4 quarts in a gallon, 4 quarters to make a whole. So degree of 4 is a quartic function. The extended version of a quartic function starts with the 4th power and descends from there. So you would start with the 4th power, and then everything else would descend in power. So bx cubed, bx squared, bx, and then e. However, the absolute lowest that you need, the minimum requirement, is to say x to the 4th. If you've got x to the 4th, automatically qualifies as quartic no matter what else is there. Okay, now that has to be the highest power. If you go above 4, it changes, but the minimum requirement for quartic is 4. All right, finally, my last named function that we're going to learn is the quintic. Quintic, quintuplets. You've had 5 children all at once. Quintic, 5-sided figure. Although this is a pentagon, so we don't call it a quintagon, it's a pentagon. But this is a degree of 5, which means that you are going up to and stopping at the 5th power. And then you can descend from there, bx to the 4th, cx to the 3rd, dx squared, ex, and then f. I shouldn't use f because f is already there, but for the sake of time, I'm leaving it. All right, so the degree of 5, all that you really need is x to the 5th. So here's what I'd like on the following slide, the next slide down. Slide answers. It would help if I spelled answers correctly, wouldn't it? On the next slide, I would like for you to tell me, name the 5, I'm sorry, there's 6 up here. Name the 6 polynomial function. We're lagging, folks. That's not good. That's a function. Name the 6 polynomial function types in order. All right, so if you wrote these down, you've already got them, okay? This slide right here has the 6 polynomial function types in order. Just make sure you've watched it and you've written them down. All right, and I'm going to stop this here, and then I'll see you on the next slide.